Welcome to this new video of my YouTube series Getting Started with Eclipse MicroProfile 3.0. In this video we're going to cover the CDI, Contexts and Dependency Injection, which is mainly used to have a type-safe dependency injection mechanism for your application. But CDI offers a lot of more features, which you will see in this tutorial. So the CDI specification is also part of, or originally comes from Java EE. It's now part of Jakarta EE, and one of the key specifications you will use in your application. So let's imagine the following use case. We have a book service class where we want to store books which have a book name and an ISBN number. And before storing these books, we want to validate the ISBN number, so to check if it's valid, if the length is okay, and if not, we want to reject it. As we don't want to have this functionality here in our book service, we have an ISBN validator class, which is just there to validate this. So it takes an ISBN number, checks for its length, and depending on the length, will either return true or false, which we can then use to either reject our book or not. So without dependency injection, what you would do, you would create an instance of this Java class with the new operator and do it on each invocation, which is not that nice, because if this class here also is depending on other classes to be created, so if the constructor takes further arguments, we have this class here, this book service class, has to know how to construct an instance of it and also do it over and over again. So wouldn't it be nice if there would be a runtime which takes place of all this in creation of Java objects, and other classes can just claim that they want to have an instance? So this is what CDI mainly does. So with CDI, there is a runtime which will manage all our Java beans and will instantiate them and distribute them to classes which want to use them. To inject an instance, we can use the @inject annotation and just claim here that we want to have an ISBN validation instance, and don't care how it's created, when it's destroyed. All of this is now handled by an external instance, which is the CDI runtime. So now if we use this @inject and annotation above our field here, we have access to it and can now proceed with writing our business logic. So here we can access it and can now say validate ISBN. If it's true, we can, let's say here, let's store the book. Otherwise, we can say don't store. So let's save and see. So here, as we try to store now two books, the first one with a correct ISBN number and the other one with a not correct ISBN number, you now see here two outputs. So we say here we don't store it, and also the ISBN validator has here a print statement where it says which ISBN number is not valid. So you see there we don't have to do any further configuration to have dependency injection in this use case in place, but there is one thing we have to configure. So within our beans.xml file, there are several bean discovery modes. So there's all, annotated, or none. And if we specify all, we don't have to add any further CDI related annotations, and the runtime will find this and create it. So once CDI manages our instances, they have a predefined lifecycle which we can intercept or can use to do further tasks. So for example, there is no way to interact with creation of this instance with the @post construct. So here we can now, let's just print out that we are constructing an instance of this class. What you could do here in theory, you could add further initialization task for this class to work. So now see here, before accessing the actual method in our book service, we get here the statement that our ISBN validator was created. So besides post construct, there's also pre-destroy. So once the instance is destroyed or no longer used, we can also have access to this life cycle with the pre-destroy annotation. So there are several scopes within CDI. The default one is dependent. So even though we don't specify it here, CDI will add this dependent scope to our bean. And the dependent scope means we are depending on the injection point. So in this case, our scope depends on the book service, and we will create an instance for the book service and don't share it with others. And once this book service is destroyed, also our ISBN validator gets destroyed. There are further predefined scopes within CDI. So for example, at request scope, with at request scope, we would bind our lifecycle to a HTTP request. There's also at session scoped. So this would be now part of a HTTP session of the user and live as long as the HTTP session is present. Another example is the at application scoped. So with this, we would create a singleton. So there would be just one instance for the whole application. And the last predefined scope is the conversation scoped, which is not used that often, but you could use it to have, if you have something like a conversation context in your web app. So for example, a wizard-like web app where your user has to fill in multiple forms, you could use the scope and bind it to a conversation. But as I said, we don't have to specify any if we don't want to, and the default one would be at dependent, and therefore be depending on the class which injects this instance. If we want to have further access or create the beans more dynamically, we can use producer methods. A good example would be to create loggers. So we can add this producers annotation to a method, and this will then instantiate beans of the type logger. And while instantiating these beans, we have access to the injection point. So the injection point is the actual place where the injection happens. So if, for example, here, this in the book service, the injection point would be here in the book service in this private member variable. And with this injection point, we can then have access, for example, to the class who wants to access or get an instance of this bean. And we can use this to configure our logger. So now we can, instead of writing here to the console with system out, we can now say this ISBN validator wants to have an instance of the logger. And then we can just say here logger.warn and print out our previous stating using a logger. You see it here with the warning statement. So we can now also use this logger here and request an instance of the logger. Let's see. So instead of system out, we can now say logger.warn, don't store, and maybe add the name of the book. And let's save. And now we see here in our console two warning statements using this logger, which was created with this producers annotation. In this example, I would have to configure OpenLiberty to see the actual class which is logging it. But if I would enable this, we would now in our print statement see the actual class which is logging it, as we use this injection point here and have access to the class. And in the output, then would see here this first message comes from the ISBN validator, as the injection point is the ISBN validator class, and the last output would be from the book service. Let's continue with the next topic of CDI, which are qualifiers. So imagine the following use case. We have a interface, a book distributor, and this interface has just one public method here. We want to distribute a book, and we just pass in the book name. And as our store has several options to distribute a book, we want to create multiple implementations of it. So we have a book plane distributor to distribute the book by plane. And we also have a ship distributor. So let's imagine we could also distribute our books by a ship. So now within our book storage, we want to inject the book distributor. So let's try to do it and let's see what happens. So now you see here in the console, the injection fails. So in the previous example where we just had one implementation, like we were relying on the actual class, here we now want a implementation of this interface, but the CDI runtime finds two. So the statement says we request a book distributor, but there are two beans which match this interface. So the CDI runtime doesn't know which one to take, which is correct, because otherwise it would be either random, which we don't want to. So we now have to somehow specify it further which actual instance we want. And you can now also see here, these two classes which implement our book distributor interface already have some qualifiers. So the default one is the @default and @any. So what we could do to remove this error message, we can also request the book distributors wrapped with the instance wrappers. This would give us all available book distributors. So if we now say book distributors stream, and for each, let's say book distributor, which books we want to distribute, let's say Java 13. So with this, we now inject all available instances and can iterate all of them. And you now see here, we now distribute it by ship and by plane. What we can also do is to write a custom qualifier, so which is an annotation and which has the @qualifier annotation inside it, and specify it further. So for example, we can create an annotation to specify plane distributors or ship distributors, and we can now use these annotations on our implementations to further specify it and qualify it with these custom annotation. So here I'm using it now, ship distributor and plane distributor. And while injecting, if we don't specify any further qualifier here, like we did when it fails, we requested the default one. But we can now say, please inject the ship distributor, and then call it also ship distributor. And now use it. So remove the previous one. And now as you see, the injection is happening, so there is no error statement, as we further specified or qualified in the context of CDI which actual implementation we want. So we can now copy this and also ask for the other one, which is the plane distributor, and copy this, and now get the expected behavior we wanted to have, and can use these qualifiers to specify which actual implementation we want to have. So with CDI, we also have the possibility to write interceptors and decorators, and I will start with the interceptors. So with an interceptor, we can intercept the call or the execution of a method and have access to several interceptors. So let's imagine we have this book payment provider class where we want to withdraw money from our customers. So we give the customer name and the amount of money we want to withdraw. And let's say we want to intercept this or to add further logic without adding it to this method. What we can then do, we can write a interceptor and specify what we want to intercept. So we can say here with around invoke, we want to intercept the invocation of the method. And now I'm specifying here what I want to do. So I'm getting access to the invocation context, which is not type safe. So we, in this case, as we know which method we want to intercept, we can get the parameters. We know the first parameter is the name. So here we can check for the name. And in case of Duke, we can now do the evil thing for setting the parameters in a different way. So we're ignoring the actual amount which we want to withdraw, but now use a hard-coded amount and say we want to withdraw 999 euros from Duke. And after this, we have to proceed this method. So the actual business method is then called, but with our modified input. To bind it to our actual method, we have to use a interceptor binding, which is also a custom annotation we can write, and this has the interceptor binding annotation. And also we have to specify that this class here is a interceptor and use this interceptor annotation from the interceptor specification. So the interceptors and decorators, as you will later see, are deactive by default, and we have to activate them. You can activate a interceptor or a decorator with the add priority annotation, or you can configure them in the beans XML and have to specify the fully qualified class name here, and this will then activate our interceptor. So let's make an example. Let's reuse our book service class here and inject the book payment provider. And what we can now do is to withdraw money. So let's try to withdraw money from John with the amount of 42 and use the same for Duke. And let's say Duke just get charged 10 euros. So let's see what happens if we save this. So you now see, as we logged in our book payment provider, how much money we withdraw from our customer. The first one is a print statement we expect. So John gets withdrawn 42, but for Duke, originally we specified please withdraw 10 euros, but now as our interceptor is binded to that method, we will withdraw 999 euros from Duke. So this is just an example how interceptors can be used. So there might be other better examples to use it if you have cross-cutting concerns you want to apply to your method. So for example, logging or security checks, you can use these interceptors. Let's remove them for now and continue with the decorators, which do similar things like the interceptors, but are more type safe. So imagine we have a interface, an account with two methods, get the balance and withdraw money, and have an implementation of this account, which is the customer account. And here are two methods implemented. Statically, we will return 42. And when we withdraw the money, we just print out how much money we want to withdraw. So now if we want to somehow extend or use the decorator pattern, we can write a new implementation of this account, and let's say large withdraw decorator. So with this decorator, we now have a type-safe approach to extend functionality, and in this case, I don't have to override every method, but I'm overriding the withdraw money method, and just print out if the amount of money is more than 100. We could do further security checks here, for example, but I'm just printing out that a large amount of money is withdrawn. And after this, I have to delegate to the actual customer account, to the actual account implementation, which is the customer account here. So therefore, I'm injecting the account. In this example, there's just one implementation, so we don't have to use any qualifiers here, and use the @delegate annotation to say we will then delegate to the actual implementation method. So we can now try this in our book service. Let's inject a account. And then don't do it here, do it in here. And say we want to withdraw money. So the first amount, let's say, is 42. That's a double. The next is 11. And the last one is 111. Let's see what happens. So as you see here, the first two withdraw operations proceed like expected. So we see here 42 and 11 is withdrawn. But for the large amount, we get this warning statement here to the console. For the large amount, we get this additional security check here, or this print statement in this example, that an amount of more than 100 euros, for example, was withdrawn. So this is how the decorator works and how you can implement it. You have to use this @decorator annotation, and like I already told you in the interceptor tutorial, the decorators and interceptors are deactive by default. So either use the @priority annotation, so you can have also multiple decorators and interceptors and specify the order with the priority annotation, or use the beans XML file and specify the decorator class which you want to activate. Well, let's remove it for now again and move to the last topic of CDI which I want to show you in this tutorial, which are the events. So with CDI we get a event notification system out of the box and can publish and listen to events in our application. You can use these events to decouple component and get this observer pattern right out of the box. And to publish events, you can inject a event instance and specify the type of the event, and then use this event instance and call the fire method, which will then fire a new event. And then you have to specify your type of event you want to fire. And on the other side, you can write listeners, so you can use the @observes annotation here and can specify for which event type you want to listen to. I've provided you an example where we listen to three kinds. The first one is we listen to default qualifiers of our book instance. So this is also now the same like you saw when injecting. This is also using the qualifier mechanism of CDI. For the next one, we listen to special books, which are foreign books. So this @foreign book is again a default, not a default, but a specified qualifier we write for our own. And while publishing, we can now here use this @foreign book annotation and can say that these book requests are foreign book requests, and so this listener will kick in as he observes the foreign books. The last example is observes async. So the two previous one were asynchronous events, but with CDI we can also publish and subscribe to asynchronous events. So to fire an asynchronous event, we can use the @fire async method, specify it. As this asynchronous firing doesn't block our execution of the method and we don't have access to result of the firing, we can register a handler and then do further tasks, for example, for an error case or for a success case if we want to. To show you it in action, let's activate it. So here you might have already seen it in the first examples. As MicroProfile doesn't have this startup annotation from EJB, I'm using this trick to somehow execute this method once the application starts. So this also here is a event observer. We are using this event observer to register once the application scoped is initialized, and then this method will be executed. So now you see here, we're firing our events. The first one is the normal event. Then comes the foreign event, which our listener subscribes to. And last but not least, there is an example for the asynchronous event once this is fired. And also here the handling is taking place. You can see here that successfully fired this event, and in the end we just print out the request again. So that's everything I wanted to share with you for the CDI specification. I just covered the basic usage of it. There's way more to explore with CDI. If you're interested in, I reviewed a nice book from Arjan and Jan, which is called Pro CDI 2 in Java EE. You can find a link of my review in the box below and have a look at it if you want to get further information or a deep dive into the CDI topic. Have fun using it.